The car suspension system is designed to have a ride support and comfort. If the suspensions are good, the shock-absorbing component will prevent the vibration transfer from the tire to the passenger. According to the road profile, vibration are transferred to the suspension store, to the chassis, to the seat, and to the passenger. This paper emphasizes on the effect of suspension parameter, stang mass, unsprung mass, damping volume, suspension spring stiffness, and tire stiffness on vertical acceleration. The suspension system is to deal with the classical conflict between minimizing vertical chassis acceleration to increase the ride comfort and keeping the dynamic wheel load small in order to ensure the ride safety. These equations of motion are basis for the Simulink model in MATLAB. This simulation will help to simulate parameters of suspension.
Objectives of the study. The main objective of the study is to maximize the overall performance of a vehicle as it cruises down the road. Specifically, it aims to create car suspension system using MATLAB Simulink, obtain numerical simulation result using MATLAB Simulink, analyze the result obtained from MATLAB Simulink model. Scope and limitation of the study. The study deals with the design and development of car suspension system, which will offer a comfortable ride. The study has potential limitations. Analyzing this kind of system, it is one of the complex tasks to design and develop among the control systems from a general point of view. It shows a limited effectiveness with respect to the road condition variation, time, and treatment of programming aspect of the issues, due to the limited analysis and design of vibration of car suspension system.
For our methodology, in this paper, the proposed system is a car suspension system responsible for driver comfort and safety. It isolates car body from road disturbances. A quarter car suspension is a suspension of 1/4 car body mass. Suspension system has three types: passive, semi-active, and active. A passive suspension has fixed damping rates determined by their design. Semi-active and active suspension uses selective damping rates. In active suspension, energy is added. This paper proposes advances to minimize sprung mass, displacement, and suspension working space using MATLAB Simulink.
The proposed system is a car suspension system responsible for driver comfort and safety. It isolates car body from road disturbance. A quarter car suspension is a suspension of 1/4 car body mass. Suspension system has three types: passive, semi-active, and active. This proposed advance to minimize sprung mass, displacement, and suspension working space using MATLAB Simulink. For the input parameters, in suspension spring, 17,474.9, tire spring, 179,913, for suspension damper, 1,328, for the tire damper, 3.70, mass, 300.5, for mass 1, 40.3. A parameter adaptive suspension control scheme is used to control presented. In this regard, the possibility of improvements in body excitement is inhibited by the use of simulations. In terms of performance, the variable damper delivers the best result. A passive suspension system is almost the same size. A spring and damper presented the suspension spring and the pneumatic damper respectively. We get the acceleration of the model because of the displacement values are low compared to the input step, indicating a large steady-state error. This is because a passive suspension system without any form of control over the plant dynamics. This can be improved by introducing feedback control, or alternatively, the plant parameters such as stiffness and damping through the improvement. the response.